What I thought I'll do is tell you about 5 unusual facts about hairs which I learned. What I'd suggest is that you just note down the answers for yourself and see how many you get correct out of 5. The first question is, do blondes have more hair than people with other hair colors? And the answer is yes, they do have more hairs than those with dark hair. We have 5 million hair follicles in our body, and only 2% of them are on the scalp. And the density is very variable depending on the color of the hair. Blonde hair have about 150,000 hair follicles. Those with darker hair have about 100,000 hair follicles. The only thing is, their hair is finer. There is lots of debate as to why those with lighter hair have more hair follicles. And one explanation may be evolution. After humans were first found in Africa and they went to more northern latitudes, they started losing their color of their skin, and they lost the color of their hair as well. But the problem is the sun was still there in the summers, particularly in the northern and southern hemispheres. So as an evolutionary defense, instead of having darker hair, it became more in density. So as soon as more density occurs, it gave partial protection for the hair. That's the reason why blonde hairs are more dense than black hairs. It's actually a recessive gene. Only 2% of those who are in the world have blonde hair. And the reason they have this finer color is because they have less of eumelanin. And another interesting fact which I found out was that those with blonde hair, sometimes it gets darker with age. When they become teenagers, with hormonal influences, the hair actually becomes darker. It's an unusual fact which I learned when I was researching this topic. Next question is, can hair taste or smell? Do they have receptors which taste or smell? Yeah, the answer is yes. We do have receptors which are actually taste receptors on the scalp. Various flavors can be detected, but they are mainly the bitter tastes. And again, there's an explanation for this. This is because early humans, when they were foraging through for food, there are lots of these poisonous substances. And one of the ways of detecting them even before you come close to them is your hair actually coming into touch with them and having these taste receptors. So you're not coming into touch with it, only your hair is. So it's an early warning system against potential dangers. Now you may think, oh, it's actually not a very relevant factor. But actually it is. Because they found that the taste receptors in the hair, this particular number, OR284, regulates the hair follicle growth. And there is actually a new agent, Sandalore, and that prolongs the active growth phase in vitro. They've published on this as well. So this came about 4 years ago, and it improves telogen effluvium associated parameters. So using these unique receptors, you can see that there is some scientific reason why we have to find it. They may actually help hair growth in the future. Next question. Is our scalp hair strong enough to support an elephant? Which means if you take all our hairs in the scalp, can it support an elephant? Yes. Okay, let's look at the facts. Each hair can support 100 grams, that's 2 candy bars, and we have 100 to 150,000, that comes up to 1,000 kilograms. So it can actually support 2 elephants. So it's a trick question. It's not 1 elephant, it's 2 elephants. I mean, such a fine thing can support so much because of its structure. It's due to the keratin, the way it's arranged in a helix shape. And this structure is very unique. It's almost like the DNA. You get these amino acids, they become proteins, and then they form tetramers, which become intermediate filaments, and they become microfilaments, and each one of them has a helix. And around this helix, which is already giving it strength, there is high sulfur content of matrix. All of this put together is what gives it so much of resilience. So this is the structure, and then you get the chemicals. You get the helix with the high proteins, you get the high tyrosinase, you get the high amount of sulfur around it, sulfide bonds. So that's the reason why it becomes so strong, and it's almost unbreakable at some point. So you can stretch them 40% before they start breaking, and the tensile strength is actually megapascals, 200 to 260 megapascals. It's almost as strong as steel. Which again, I'm sure most of you would have got it wrong because you would have said 1 elephant, but it's 2 elephants. Now next, hair is the fastest growing tissue in our body, true or false? So what is the fastest tissue? Yes, it's the bone marrow. So bone marrow is again I put that to trick you. You'll say yes to everything. So bone marrow is the fastest growing tissue, but hair is the second fastest tissue. It grows by about 1.25 centimeters a month. So over a period of 6 months, it grows by about 6 inches. And it's a constant stage of growth, anagen, catagen, telogen. But why is it that hair is in different parts in different lengths? Why is our hair so long in the scalp and why is it short in the eyebrows? And that's because of the duration of the anagen. So each hair follicle in the scalp goes through about 10 to 30 cycles, and the anagen there lasts 2 to 8 years. But in the eyebrow, it only lasts 2 to 3 months, and there are much less cycles. So that's the reason why the length is different, and also the way it behaves in the long term is different. And finally, can hair grow after death? It can. Again, we'll have to define what death is. So death is not a single event. In fact, there's a very nice quote which I've written there. We are all born with a terminal disease called life. We all know we have to die. So we are all born with this terminal disease. And we think death as being just one instant where we think there's loss of brain activity, you lose your breath and you lose your heartbeat. But actually it's much more than that. You get these cellular changes and the biochemical activity decreases, and that takes many, many days. What actually happens in the hair, it's actually a false growth. What happens is that the hair looks like it's growing because the skin dehydrates and retracts from these biochemical changes. And this exposes more of the hair shaft, and that's why it looks as though the hair grows more. It's an apparent growth in the hair. So I hope you liked all these unusual facts. Thank you.